Hi, this is Julie. In this video, we're going to take a look at some examples of expressing inequalities. First off, let's take a look at a statement here. The number of people in the room is 5. If I wanted to write an equation to represent this statement here, first thing I'd want to do is pick a variable. So I might pick P for people. And since there's just 5 people in the room and there's exactly 5 people in the room, I could say that P, the number of people, is equal to 5. And if I wanted to mark that on the number line, I can set up a number line here. We'll put 0 over here, and then 1, 2, 3, 4, 5. And I can mark a point just right here at 5 on the number line. And so that point would represent the 5 people who are in the room. And since it's just one single number, I just put 1 point on the number line. But what if I had a statement that represented more than one person or more than one possible answer or value for the variable? Well, we'll look at some examples like that. So here's the next one. In this statement here, ice turns to water when the temperature is above 32 degrees. Well, there's lots of different temperatures at which water or ice would turn to water then, right? Again, I can pick a variable to represent what I'm talking about here. So I'm talking about temperatures. So I'm going to pick T for my variable. And what I want to do is write a statement that says that, or that will represent all the temperatures at which ice turns to water. And I'm going to base this on 32 degrees. And what I want to say is that when the temperature is above 32 degrees, ice will turn to water. Well, that means that T is going to be greater than 32 degrees. And if I was going to mark that on the number line, back to my number line again here, I'm just going to put 0 down here, and so here is 10, and here's 20, and 30. What I'd want to do, so 30, mark, here's 31, here's 32. What I want to do is mark all those points that are greater than 32. So technically, I could put a point here where 33 would be, I could put one where 34 would be, and 35, and so on, and actually even like 32 and a half would be included. Really anything that's above 32 would be included in my solution there. Those would be reasonable values for a temperature at which ice would turn to water. I'm not going to include 32 itself, because at exactly 32 degrees, that water is still ice. But at 32 and a half degrees, it's going to turn to water. So the way I'm going to represent that is I'm going to put an open circle around 32. I'll just mark that this is 32 here. So I put an open circle to represent that exactly 32 is not included, but anything, even just the slightest amount above 32, would be a temperature at which ice turns to water. And then, of course, all of the bigger numbers above 32 would also be temperatures where ice would turn to water. So let's look at another example. All right, so you go to an amusement park and the sign says you must be 60 inches or less in height to go on this ride. So if I was going to write an expression for this, and I wanted to write an expression for all of the heights at which you could go on the ride, I could use H for height, and I would say that your height has to be 60 inches or less. Well, how do I indicate that it's 60 inches or less? Well, I know that I can say that the height has to be less than 60 with a less than sign, but if I want to, if I want to include 60 in the possible heights, there's another symbol I can use, and it's called the less than or equal to symbol. And basically it looks like a less than sign with a little line underneath it. So it's sort of like a combination of the less than sign and the equal to sign, and it's less than or equal to. So I can say that the heights would have to be less than or equal to 60. And again, if I wanted to mark that on the number line, we'll put 0 will be way down here. Here's 60 way over on the other side of the number line. What I can do is put a mark at 60, and this time, because 60 is one of the possible heights, you can be exactly 60 inches tall and still go on the ride. I'm going to fill in that dot to show that 60 is included. So last time we left the dot open because the value where the dot was not included. Now I'm going to fill it in because 60 does work in this scenario. It is included. And then anything less than 60 is included. So I'm going to go ahead and draw in a line that covers the rest of the number line with an arrow going to the right. Now, of course, in real life, there's no negative heights. You can't be negative inches tall. But for the purposes of just giving an example on the number line, I'm going to go ahead and draw my line over the negative values as well. And then I put an arrow on the end going to the left to show that all of the lesser values would be included. So let's look at a couple more examples here. So here's an example where now we're going to look at a range of temperatures. So the lowest temperature ever recorded was negative 129 degrees. That was in Antarctica. And the highest temperature ever recorded was 134 degrees, and that was in Death Valley. So what I want to do is show the range of values that have ever been recorded, of temperatures that have ever been recorded in history. And what I want to say is that those temperatures are in between negative 129 degrees and positive 134 degrees. And again, I'm going to use T for temperature, and I want to show that all those recorded temperatures are in between negative 129 and 134. And I'm going to kind of break this down into parts right here. And what I'm first going to look at is that I'm going to look at the relationship between negative 129 and all of the other possible recorded temperatures. Well, I know that negative 129 is the lowest temperature ever recorded, so that means that T has to be, all the other temperatures, which is what T stands for, have to be greater than negative 129. And so I'm going to write that this way. I'm going to say that T is greater than or equal to negative 129, which of course means that negative 129 is less than or equal to all of the other temperatures. Now I'm going to look at the other end of the equation here, or the inequality here, and I want to look at the relationship of T and 134. So all of the other recorded temperatures in history have been less than or equal to 134 degrees. 134 is the highest temperature ever recorded. So I'm going to write that T is less than or equal to 134 degrees. And on my number line, the way I'm going to show this is I'm going to put negative 129 down here at the left end of the screen, and 0 would be somewhere in the middle. And 134 is going to be over here on the right hand side of the number line. And I am going to include negative 129 and positive 134 because those actual temperatures were recorded. So I'm going to put solid dots over those two values. And because all of the other temperatures were in between those two values, I'm going to fill in the part of the number line that is in between those two numbers. So there won't be anything on the two ends because there's never been a temperature lower than 129 recorded, and there's never been a temperature higher than 134 recorded. So I'm only indicating the temperatures in the middle. All right, a couple of last examples. So all of the inequalities that we've looked at so far have basically been solved for us. They've shown us the relationship between the variable and another number. What we're going to look at now are some examples where we basically are given a little, we have some steps to do in order to figure out what the variable is. And we're going to solve these just like we did equations. So same exact steps, we're going to use the same processes, and then we'll just graph our answer on the number line. So if I need to solve 4x plus 3 is greater than 15, I'm going to start off by subtracting 3 from both sides. That gives me 4x is greater than 12. And then I can divide both sides by 4. And what I'm left with is x is greater than 3. So I can go over to my number line. We'll say that 0 is right here. That means 3 would be over here to the right. Since my answer here, my solution is x is greater than 3. It's not greater than or equal to, it's just greater than. I'm going to put an open circle around the 3, and then I'm going to mark all of the values to the right of 3. So everything that is greater than 3, bigger than 3, on my number line. And that would be the solution to that inequality. If you want to put an x up here to show that it's x that's greater than 3, you can do that. All right, let's look at the next one down. So this time I've got a little bit more work that I have to do. I have to do some distributing here. So I'm going to distribute the 2 through the n minus 1 in parentheses. So 2 times n is 2n, 2 times 1 is 2. So I've got 2n minus 2 is less than 8. I'll add 2 to both sides, and that gives me 2n is less than 10. And then my last step, and I'm not going to show the division here because I'm running out of room, but my last step would be to divide by 2, and so n is going to be less than 5. So again, I'll go over to my number line, put 0 over to the left here, 5 over to the right. Since n is less than 5 but not equal to 5, I'm going to put an open circle around the 5, and I'm going to fill in the part of the number line that shows all of the numbers that are less than 5. So that would be the part to the left of 5. And again, put an arrow on the end of that line. And that would be my solution here. And again, if I want to put an x up here to show that those are the values of x, or actually I guess it's n this time, isn't it? So let's get rid of that. And we'll make this an n instead. Last example. This one's going to be a little bit trickier. I'm going to start off the same way and add 3 to both sides of the equation. I'm going to combine like terms. When I do that, I'm going to put this, we'll do this next step down below here. Negative 24 plus 3 is going to be negative 21. And on the right hand side here, the 3's cancel out, so I'm left with negative 3m. And then I have to divide. I'm going to divide by negative 3 on both sides. And when I divide negative 21 by 3, I'm going to get 7. When I divide negative 21 by negative 3, I'm going to get positive 7. When I divide negative 3m by negative 3, I'm going to get m. And what gets tricky here is, let's think about this. If I leave the greater than sign there, this is telling me that all of the values of m that are less than 7 should make this inequality true. So imagine that I pick 1 for m. 1 is less than 7. I could take 1 and I could stick it back into this equation. And let's do this over to the side here. If I did that, negative 24 is greater than negative 3 times 1 minus 3. Well, let's see if that's true. That would tell me that negative 24 is greater than negative 3 times 1 is negative 3, minus 1 would be negative 6. Well, that's not true. Negative 24 is not greater than negative 6. So, not correct. Let's try another value like that. We'll get rid of this here. So, let's pick another number that is also less than 7. Let's pick 2, for example. So negative 24 is greater than negative 3 times 2 minus 3. Well, negative 3 times 2 is negative 6, minus 3 is negative 9. Is negative 24 greater than negative 9? No, it is not. This is not correct either. So we've got an issue here with the fact that we have a greater than sign in the inequality. And the rule for this, and the way that we're going to fix this, is that when we go back, let me get rid of this here. Oh, that's going to get rid of everything. When we go to our last step, I'm going to cross this off right here. Last step in solving the equation, Still going to divide both sides by -3. That's going to give me a 7 on the left. It's going to give me m on the right. And the rule is whenever I divide by a negative or multiply by a negative, I'm going to flip around the inequality sign. So I'm going to change that from a greater than to a less than. Okay, so let me say that again. And when I divide or multiply by a negative number in solving the inequality, I'm going to flip or switch the inequality sign. So in this case, it went from a greater than sign to a less than sign. Now when I go to graph, I'm going to have, so here's 0, here's 7. I'm saying that 7 is less than m. So 7 is less than all of the values that would make this inequality true. So first of all, open dot around 7. And then what I really want to mark is all of the numbers that are greater than 7. I want 7 to be less than all of the numbers that I'm marking. And so that's going to look like an arrow to the right, or everything filled in to the right with an arrow pointing towards the right. All right, so these are several examples that we went over in class of how to solve inequalities and mark the solutions on a number line. From here, we'll go on to graphing inequalities on a coordinate plane, so inequalities that have both an x and a y in them. But that will be for another video. Thanks for watching.